Okay.
Viewpoint.
So thank you very much, everyone. I am Joe Fairley. Sorry I couldn't be there in person. Unfortunately, the weather had some other plans for me and I had a canceled flight. So the digital theme here will go well with my presentation on how do certified prosthetist orthotists and their technicians go digital. Today we're going to take a deep dive into the options and pros versus cons for in-house and outsourced digital workflows for prosthetics and orthotics. So I am the founder of Ascent Fabrication. It's a fully digital central fabrication company. Our mission is to provide accessible digital workflows which assist in prosthetic and orthotic companies in the implementation of additive manufacturing while designing and fabricating highly functional and innovative prosthetic and orthotic devices. So I'm going to start with the question, why should we use a digital workflow? Well, first off, we don't have any positive molds. We are reducing waste and raw material usage that way. We are using additive manufacturing, not subtractive, so we're only really using what we need in terms of materials. Once you get down to a very proficient digital workflow time, this in most cases is drastically less than the traditional amount of fab time for hands-on work. It can reduce the shipping time and costs to send a digital file versus sending off a cast. We can get into innovative designs that cannot be fabricated traditionally or would not be efficient to do so. We can operate on a smaller footprint with lean manufacturing. My office currently is out of 120 square feet in upstate New York. Then we might also have some more patient care time and volume. We would see that increase as we're able to decrease our times utilizing digital workflows. So first we'll talk about what is not digital. And in the parentheses, I'll have the number of kind of main steps that we use in order to get to those end products. So in the traditional sense, we take a clinical assessment, we go through cast, we use plaster modifications, we go through a fabrication process, and then we go to a fit, align, and measure an outcome for 5 main steps in that whole process. Now this would mainly be for maybe a first test socket, and additional test sockets and whatnot. Other devices would just add on more and more office visits and steps to this process. So you can see below, additionally, we would repeat the process here. So when we talk about going digital, we're going to start off with a few scenarios which are what I would call quasi-digital. We could do the clinical assessment, take a cast, do our plaster modifications, then we could 3D scan the mold. Then we could go to carving and fabrication and fit, align, and measure an outcome. Now we've increased the number of steps by 2. For additional sockets and whatnot afterwards, we could fill that device, do more plaster modifications, 3D scan the mold again, and go through the same process for carve, fit, fabrication, fit, align, and measure an outcome. One alternative would be to do the clinical assessment, take a cast, and we could 3D scan the inside or outside of that cast, and then go through digital modifications, and then back to carving, fabrication, fit, align, and measure an outcome. In order to get to the second phase, we could spray paint the inside of that socket a matte black finish, then 3D scanning the inside of the socket, do more digital modifications, carve, fabrication, and so on. The next scenario would be clinically assessing, taking a cast, doing plaster modifications, 3D scanning the mold again, but this time we go to 3D printing and fit, align, and measure the outcome. Once again, we could fill that socket, do more plaster modifications, 3D scan the mold, then back to 3D printing and fit, align, and measure an outcome. So we're getting towards some different fabrication techniques here. 2 more scenarios here. One being we could clinically assess, we could then 3D scan the patient themselves. We could go through digital modifications, carving, fabrication, and fit, align, and measure an outcome. Back to possibly spray painting the inside of the socket, 3D scanning the inside of the socket, and then go back to our digital modifications and carving. The next scenario here would be clinically assess, cast, 3D scanning the inside or outside of that cast, back to digital modifications and 3D printing, and then fit aligning and measure that outcome. Spray painting the inside or outside of spray painting the inside of the socket, 3D scanning the inside of the socket, doing more digital modifications, and 3D print and fit align and measure an outcome. So we see here how the number of steps can increase with the kind of hybrid approach that we do, but this is a great way to get started with going digital. Oh, I guess I went back one. So one scenario that I'd like to walk you through is one with one of my customers here. We went through a quasi-digital approach where the clinician here clinically assessed the patient, he casted the patient, did his own plaster modifications, he fabricated a traditional test socket, and then he fit that first test socket. Once he made a couple adjustments to that test socket, and he indicated there on the socket where he would want some cushion buildups for a flexible inner socket, he shipped me that socket. I was able to spray paint the inside of that socket matte black, 3D scan the inside of the socket. We did a few digital modifications, and then we 3D printed the flexible inner socket and the frame. The frame was printed with a polypropylene material, and the flexible inner is a TPU that foams as it prints, our foam flex air socket. So Casey Gruber here from Evergreen PL was very interested in this kind of hybrid workflow, and he was really pleased with the results for this particular patient. I would like to read a few notes directly from Casey's own words for you here. The workflow is very similar to what we do in our clinic. We casted the patient with plaster, fit 2 check sockets, and then went to laminate. The only difference was that one of the check sockets was fit with the foam flex air inner and a polypro check socket frame printed around it. This was great because it gave the patient a chance to use the flexible inner socket before we went to final lamination and give feedback. And it gave me more information on how the final prosthesis would fit versus going from hard check socket to the final. It was also great because we were still able to laminate the final socket in-house because we could fill that polypro frame and would laminate over that. I asked the patient for some initial feedback, but was not expecting a lot of positivity right away, considering his history of discomfort that he's presented with, painful neuromas and very sensitive bony anatomy around the distal tib, medial condyle, and fibular head. He's tried various systems over the last few decades and previously used a ProFlex flexible inner socket. Casey's own words here, he said that compared to his previous sockets, this material was like walking on air. He remarked that it felt noticeably lighter right away and that he wished that he had this 15 years ago. The built-in air pockets and distal end pad allowed for inherent relief and comfort without sacrificing total contact. Besides that, what I really loved hearing as his prosthetist was that he felt like he could fully load the prosthetic side, taking stress off the contralateral joints and allowing him to get more energy return out of his K3 foot. He even started jogging around the office, something he hasn't been able to do in a very long time. So this was a fantastic outcome, but we probably could have reduced a few number of steps by going more of a digital approach. So here's that fully digital workflow. We talk about doing the clinical assessment, 3D scanning the patient directly, doing digital modifications, going to 3D printing, and then fit aligning and measure our outcome. We're back to that 5 main steps from the traditional steps that we took to get to the first test socket. Here you could use the COMAP. Pictured in the middle is PVA Med's Rapid Plaster software and printed in PETG test socket on their Emergence Pro 3D printer. Also going fully digital, this was a project that I went through with University of Texas Southwestern with their professors and students there. The students clinically assessed each other. They 3D scanned their other student with comb. Using the iPhone 10 or newer front-facing camera, they were able to get that 3D scan. They went and then did digital modifications in the Mercurus software. And then I 3D printed 2 different devices for each of them, a FDM polypropylene and SLS PA11 nylon solid ankle AFO. And then they fit and measured and align those outcomes there to see the differences in materials and different printing properties, how those compared to each other. These are some other examples, other pictures of the SLS PA11 AFO. So when we get into the different options for 3D scanning, right? I have mentioned comb already here. These are the different iPhones that it's currently compatible with. I know they're working on iPhone 13 and upcoming 14 as well. When we talk about the ease of use for 3D scanners and their entry point for the monetary investment that you have to make, for $750 a year per user, comb is a very accurate scanner for what we need to do. Within 1 to 2 millimeters of accuracy, which I have found is more than accurate for a lot of upper lower limb prosthetics and lower limb orthotics as well. You could go for other scanning solutions on the iPhone. There are plenty of them out there that range literally quite from $3 to $30, depending on paying per scan or paying for the full application. The problem with these scanners is you really do get what you pay for. With Comb's app, there are back-end algorithms that enhance the accuracy of the scan itself, including different bounding boxes, the area of what you're actually scanning, to make sure that the accuracy is indeed as accurate as possible. A lot of people know about the iPad structure sensor scanners, either the Mark 1 or the Mark 2. The Sensor Pro is the newest option there. Structure actually no longer really supports the Mark 1 or Mark 2, and we'll get into kind of some reasons why here in just a little bit. What you would see here on the right is a picture of someone utilizing actually Oster Design Studio's scanning application. And what I would critique here just a little bit is that the bounding box is a little bit wider than what we probably should be scanning. We really just want to scan only what we want to actually modify. There's other applications out there on the iPad, from Spinal Tech, Tuan, Captiva Plus, TechMed 3D we'll get into as well. These are all kind of at the same price point as what Comb would be if you're looking to initially get into buying a new scanner. The new hardware, the new software, you're all in at about $1,000 for either comb or structure sensor. There are several foot orthotics and podiatry applications out there for the structure sensor. Again, it's just a matter of really who you interact with, what company you're dealing with, and what little nuances they have with their work order. Now getting back to the iPad and the Structure Sensor Pro. So on the right-hand side here, we do have a couple histogram graphs. The top histogram graph is showing the structure sensor Mark 1 and Mark 2's calibration accuracy over a number of scans. And how wide that accuracy really is affects those outcomes in the 3D scan itself quite drastically. They have since decreased that range to a very narrow point there with the Sensor Pro. So hopefully the accuracy will be getting, within less than 5 millimeters plus or minus there. Straight from Captiva Plus though here, they call it a compact and highly accurate plus or minus 4 millimeters at a distance of approximately 40 centimeters. Again, I don't know if I would quite call it highly accurate at plus or minus 4 millimeters. That could be the difference between a well-fitting socket around the fibula head or possibly having some skin irritation and breakdown over that area. So let's get into some of the other scanning solutions as a software as a service. TechMed 3D, we've mentioned, has many applications out there with several different central fabrication companies. They have their MSoft solution where you can use a myriad number of different 3D scanning solutions. And Ortho America, I've seen, is the only one to actually be on an Android device. If we get into the higher end 3D scanners, we're getting upwards of $8,000 to $10,000. Now you could have an accuracy of up to 0.5 millimeter or possibly less here in this case. So it really just depends on what you're scanning, how accurate you really think you need to get with some of these scans, and or do you modify your workflow a little bit in order to get to what you need? Peel 3D, Vorum, Rodin 4D, and Willowwood obviously are a few examples here. Autobach has even come out with their own 3D scanner recently with their Easy Scan and iFab solution. They're also getting into 3D printing with HPMJF technology, so that'll be interesting to see in the future here. I have walked through one work order with the Easy Scanner so far with one customer, and the results were very, very close to what the comb scan gives us as well. Now when we get into digital clinical modifications, as again a software as a service solution here, we do have Oser Design Studio, PVA Med's Rapid Plaster, Willowwood Omega software, all differently used for prosthetic devices, could possibly used for orthotic devices as well, but might have some slight nuances. Each one has their own pros and cons for how user-friendly it is to actually learn what the tools are in the software. Are they named similarly to what we're already used to using with our hand tools? Or are they a little bit more engineering heavy than some other softwares? Getting into maybe a little bit more engineering heavy, we do have Vorum. Vorum has a very wide range of opportunities there for different devices, obviously. But then we get into two newcomers here into the field, Spentis and Mercurus as well. Spentis being Belgian, Mercurus being German. They have increasing offerings now. Spentis started out in upper limb orthotics. They're now getting into lower limb orthotics and exploring some prosthetic options as well. Mercurus has started out with lower limb orthotics and is now diving into a little bit more prosthetics and expanding their options also. Again, different options for different people depending on the size of your clinic and exactly what would fit your needs for the devices that you see. Some other options, more so on the engineering heavy side again, would be Rodin 4D and Neo. Vitruve is another newcomer from France to the solutions. They are very heavily prosthetic oriented right now, but have some very, very clinically minded step-by-step workflows in place. Newly announced from Proteor is the Orton shape, and they are quite interesting to take into account right now. If you haven't heard of Orton, I would definitely suggest reaching out to a Proteor rep and getting a demo of that. So now for our additive manufacturing techniques, right? We do have FDM or FFF 3D printing, fused deposition modeling, or fused filament fabrication. That would be the layer by layer process by which we use spooled filament into creating a device. So these are some of the options here that you can see. Filament Innovations and PVA Med have very large scale 3D printers that can print just about anything that we would ever need to, from hard materials to soft materials, and they're doing a lot of exploration into different avenues there. Some other notable companies here, Essentium, Raise 3D is also a good option for large format 3D printing, but takes a little bit more experience to operate exactly well. Tractus 3D, another large format 3D printer, and then some other smaller format 3D printers here, FL Sun, Ultimaker, BCN 3D, Sidewinder Artillery, Lulzbot, Craftbot. When you get into Markforged, they have more metal 3D printing and carbon fiber and fiberglass 3D printing, which is a whole different area that we're just starting to explore now. When we talk about different materials for specifically FDM, FFF, selective laser sintering or SLS, and HPMJF or multi-jet fusion, these are some of the materials that you could notice here. PETG for test sockets, TPU for flexible inner sockets, polypropylene or CPX from Filament Innovations as more preparatory socket material into longer term use, polycarbonate, carbon fiber and fiberglass, and PA12 and PA11 nylon. Some of these materials are offered through these different partners of ours, as well as through Braskem, BASF. They're kind of helping to lead the field in that sense. Now we get into the more heavy-ended additive manufacturing, more industrial 3D printing. We do have multi-jet fusion from HP. Now, these systems tend to take up very, very large rooms. You see there's multiple different stations here. It's not just a print and go scenario. There's longer print times, a lot more involved with post-processing, and there's quite the higher price tag along with it. I would like to read just a quick definition of multi-jet fusion. It uses an inkjet array to selectively apply fusing and detailing agents across a bed of nylon powder, which are then fused by heating elements into a solid layer. After each layer, powder is distributed on top of the bed, and the process repeats until the part is complete. Another different option for this type of industrial 3D printing is selective laser sintering. SLS is an additive manufacturing technology that uses a high-powered laser to sinter small particles of polymer powder into a solid structure based on a 3D model. Sintering is to make a powdered material coalesce into a solid or porous mass by heating it and usually compressing it without liquefaction. EOS, Farsoon Technologies, and Formlabs are some leaders in the SLS side of the additive manufacturing field today. So I mentioned post-processing. Some post-processing does go on with our FDM and FFF prints. When we get into either vapor smoothing or tumbling, shot peening, and blasting, those are all smoothing techniques for the outside of the socket to blend those layers together and help create greater structure to the device. We could also anneal, and some of these technologies incorporate annealing within that process. That's actually heating up that device to a specific temperature where you're actually reducing the amount of stresses in between the layers. The AMT Post Pro and Dimension are two different companies offering different post-processing solutions for vapor smoothing, dyeing. Even you can see some of the colors there that are quite vibrant there from Dimension. So let's talk about a little bit about some of the pros and cons for either going central fab or in-house, and what are some pros and cons for both here. For a central fab, you may have less overhead cost for that clinic. You have specialized roles within the central fab that you might not have in the clinic. We talk about maybe a new digital technician coming into play with some companies, or a prosthetic engineer. We can have reliably sourced materials and fine-tune workflows. The CFAB is working day in and day out to refine those processes, whereas a clinic might not have that time to do so. They're taking on the burden of keeping up with the additive manufacturing field. The bulk of it is the AM field is quite drastically changing almost monthly. And to keep up with this field is a sprint. And sometimes we have to stand back and watch from afar for a little while we start to adopt some lesser forms of industrial manufacturing until those processes can become a little bit more available for our clinics. Central fabs might have a little bit more time for testing some of their devices as well. Again, in a busy clinic, you might not have that time. For in-house, you might need to hire new technicians or teach current techs new skills. You would also have maybe a different turnover of skilled workers, and where does that leave you once you're training up someone in a digital workflow? Again, it might not be as time efficient clinically in some cases, although you might have less shipping logistics. Again, you could send out a 3D scan to a CFAB or to somebody else to be 3D printing, doing the digital modifications. And you might not have to charge as much for the shipping there. You might also be able to keep your proprietary IP in-house. I understand that's a definite need for a lot of companies. For both, the turnaround time is really similar, whether or not you are doing 3D printing and a digital workflow in-house or through a central fab. The turnaround times are quite similar. You could have innovative devices out of both instances, and I'm sure in both instances we're both being patient-centric in our devices. So I talked about a digital technician or a P&O engineer. Again, why would you maybe want to start out using a couple devices from a CFAB before getting into some of this stuff yourself? You could go through a training phase with someone like us from Ascent Fab, where we would come into your office, do an on-site visit, and go through every step of using a 3D printer and some of the software programs in order to get to some of these end results that you see here. Using all these different devices, we're starting to take on a little bit of a different technician here. And again, could be learned by a lot of technicians that are already in the field. I've had some older techs that are really interested in wanting to learn more, and some newer technicians specifically being hired in the field to come into this more digital space. So thank you very much, everyone, for going through this with me today. Again, I apologize this was virtual. Just remember, 3D printing is not just for your projects, but it is for production. So thank you to our partners here. And I wanted to just leave this up here. If you'd like to schedule a meeting with me either today or tomorrow, I'll be available. Please take out your phones and scan the QR code there. You can schedule a meeting at a time frame that works for you. Definitely reach out to us at ascentfab.com or look at our LinkedIn or Instagram page. And yes, thank you very much for having me today.